Well, let's look at expectation x1. How do we write generally expectation? Summation x px. Summation x px. Now, if I'm writing expectation xy, then how would we write it? Summation x. Summation. So suppose I say x takes values from. I call x values as I. X is equal to 1 to 3 is. I call them I, subscript I, and I denote y by subscript j. Then I say x takes a value from I and y will take values from j to whatever the values they are. So I'm not doing just summation over 1 but summation over x and y both, right? So x and y, then summation x px. Now my x is actually z. What is z? Z is x and y both, right? So xi into yj, right? Xi into yj. Now px. Px is what? Right? Pz. What is pz? Pz is x takes a value xi and y takes a value yj, right? So this would be probability that x takes a value xi and y takes a value yj. This is my expectation of a jointly distributed variable, expectation x, y. So in case of my own this example, how do we write this? I would write this as expectation of xy is equal to summation I is equal to 1 to 3, 0 to 3, right? J is equal to 0 to 5, xi, yj, probability that x takes a value xi and probability y takes a value yj, right? This is how I would perhaps do it. Now say suppose I am doing it for say x is equal to 1. X is equal to 1, because if I do it for x is equal to 0, x takes a value 0, everything would be 0. So if I do it y is equal to 0 would be 0. So let me do it for x is equal to 1. So how do I do it? Say which actually mean that I am taking I'm solving it for x is equal to 1, not for the entire of the expectation. Okay, then I do it and then I would add all of them. So let's do it probability. So what I'm actually working through is probability of x takes a value 1, y takes a value whatever it takes. It will take value from 0 to 5. So if I have to work it only for x takes a value 1, because x takes a value 0 has no much point in doing, because everything would be 0, then I am doing summation only for j, right? Summation j is, what would be this? X, xi, but now I have taken x is equal to 1, so x actually will take a value 1. Y will be yj, I will take all the values of y into probability of x is equal to 1, y is equal to yj, right? This is what I need to solve to get the get this expectation for x is equal to 1. Okay, x is equal to 1. Then I would solve it for x is equal to 2, then 3, and then I would add all of them, right? So what I'm doing is I'm setting the value of I is equal to, I said for the first time I is equal to 0, but I is equal to 0 is going to be 0. So I'm setting now I is equal to 1. Now if I set I is equal to 1, j x is 1. This summation right now doesn't come into picture because now this is said to be 1. x1 yj, probability that x is 1, y is equal to j. Now, how do I work it through? Probability, basically x is equal to 1, y is equal to j. If I take y as 0, no point in further computing it, so I take y is equal to 1, y is equal to 1, x is equal to 1 is some probability. Y is equal to 1, x is equal to 1 is 3 by 32. Right? Probability of x takes a value 1, y takes a value 1, right, is 3 by 32, right, multiplied by x is 1, y is 1, done, plus x is 1, y it takes a value 2, into probability that x takes a value 1, y takes a value 2, that is 6 by 32, plus x takes a value 1 into y takes a value 3 into probability of x takes a value 1 and y takes a value 3, that is 3 by 32. Plus, rest are 0, so I'm not writing, so I would simply say 0, 0. Okay, those probabilities are 0. And so, if I add this up and get this, then this results into, well, I've done the calculation, so I might as well write the answers. 0.9375 plus 0.375 plus 0.28125. This is equal to 1.593. This is when x is 1, x is 0 is 0. Okay, y 0 is 0. So we are through with this. So I'm not now writing everything because it will consume a lot of time of the class. If I said this, x is equal to 2, so summation of j, x is 2, y is j, probability that x is equal to 2, y is equal to yj. This has been worked out, so it is 2.25. If x takes a value 3, j, x takes a value 3, yj, probability that x takes a value 3, y takes yj is 1.40625. Okay, what I would argue is that you guys please solve this and then verify it on your own. Is it okay if I erase this? Okay, so if I want expectation xy, then this would be 1.593 plus 2.25 plus 1.40625, which is equal to 5.25. Okay, this is equal to 5.25. Yeah.
So down there we haven't written 1 summation I, we haven't written 1, but then in the second one we got to write 2, right?
Where?
The summation I, the first, before summation j we write summation I.
This one?
No, before that we write summation I, right?
Yeah.
Yeah, so in the second one we got
This
the
we did not write summation.
because it was 1.
Yeah, it's said
But
to be
in the
1.
second it's
Here
2.
we set it to be 2.
So
Here
we write
we
it.
set it to be 3.
So
See,
write
we
it.
are doing summation of summation. Right? Summation of summations means what? I takes a value 1, you do the summation. I takes, let's do it this way. I takes a value 0, do this. Now if I takes a value 0, that is x will be 0, probability of this is 0, everything is 0, this sum is 0. So sigma j is equal to 0 to 5, this sum is 0 if I takes a value 0. I takes a value 1, you carry out this sum turns out to be 1.593.
So
Now, yeah.
the probability is wrong because it's above 1 then.
This is not probability.
It's,
We are computing expectation.
but still we did 3 by 32, it's not.
Yeah,
It's
0.0937.
So you're saying this
Yeah.
should be 0.9.
So the total will be 0.75.
3 by 32 multiplied by 3, right?
That
Three by 32 multiplied by 3 is 28.
not gram on the first value. 3 by 32. Only 3 by 32.
3 by 32.
The first value.
Which one?
3
by 32 into 1.
Yeah, 3 by 32. Would 09375. Yeah,
So the
you're
total
right.
is 0.75. Not
So
1.
the total is,
0.75.
so this total changes, right? Yeah. Thank you. This is 0.75. I corrected my end as well. This total is incorrect. Because this value is incorrect.
किया है, हाँ किया है। X2 किया है तो X3 किया है ना।
Thanks.
हाँ 2 information दिया तो
This entire thing was needs a correction, which also means that then have you done the other part?
no.
Work through and let me know if there's anything to be corrected. Then even this number would get corrected. Let's do it. So it's 1 into 3 by 32 plus 2 into this you have done, right? We'll have to do a lot of things. Let's not do it. You verify it, and wherever there is correction, please let me know. Yeah.
So coming back to that, why are we writing 2 down with summation j for the second one when x is equals to 2?
Yeah, we are not writing because it's going to be. See, yeah, that part I did not explain. I take value 0. You are doing this summation for 0. It's 0. We're not concerned. I takes value 1. We're doing this summation for 1. So I need not write this. I'm doing only this. I'm not writing this. Okay. So that's this part. Right? Then I will take a value 2. Then I will solve this sum for I is equal to 2.
And then you add the whole.
Then that is 2.25. Okay? And then I solve it for I is equal to 3. I solve this again, this summation. This summation is solved here. This is 1.406, so on and so forth. And then this sum is sum of
1, 2, 3.
1, 2 and 3. Right? So actually I should be writing this,
Whole bracket.
a full bracket, then this afterwards,
Whole bracket.
then plus this. Would be too much to write, so we are doing it separately for j is equal to 1, 2, 3, 4, whatever it is. Right? No, x is equal to 1, 2, 3. And j is allowed to take all the values. Right? Fine. Thanks for pointing that mistake. Well, we would now look at the last and perhaps quite useful part, and that is conditional probability. If you perhaps understand the logic, then these are marginal probabilities.
The second one.
Marginal simply means that the things that are written marginal.
And then the inner circle is joint probability.
Yeah. These are joint.
Now what is this?
Now we are looking at conditional probability.
It's become over the top now. It's over the
Right? Now we would look at conditional probability. Yeah. No, we'll finish conditional probability and then we take it.
Yesterday's case.
Because it makes sense to finish this discussion and then we take, if you wish, 15-minute break. More than that. Okay, today is this. Well, now in conditional probability, we are actually looking at probability that x takes a particular value given that y has taken a particular value. Okay? Say for example, I am interested in, say, suppose I am rolling 2 dice. Okay? The simplest of the example that comes to my mind is I am rolling 2 dice. So I have, if I have to draw a distribution like this for dice, then say there are 1, 2, 3, 4, 5, not 2 dice, 1 die. Okay, there are 1, 2, 3, 4, 5, and 6 possible outcomes. Each outcome is equally likely. Now I also create another condition, and that is the outcome is either even or odd. Okay. Now, since it's a odd outcome, the probability of this outcome I would write here. It's 1 by 6, 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 and 1 by 6. The rest would be zeros. And the marginal probability of odd outcomes is 3 by 6. This is also 3 by 6. And this would be 1 by 6 for each of the outcome. Okay? Now, I am interested in asking a question that if I call say odd as even as 1, this particular variable I call B, this I call A. Okay? So, if I roll a die, what is the probability that I get 6 on a die? 1 by 6. Right? But if I roll a die and I know that the outcome is even. The outcome is even. So B takes either this value 1 or 0. I call them these values 0, 1, 0, just for the nominal purposes. There's nothing great with these values. There's nominal values 0, 1. So if I know that B is equal to 1, given that P has taken a value 1, see, probability that A is equal to 6 is 1 by 6, right? A is equal to 6 is 1 by 6. But given that B is equal to 1, what is the probability that A is equal to 6?
1 by 3. If it's B, 1 even number.
Okay, what is the probability that A equals to 6 if B equals to 1? Given that B is 1, what is the probability that A will take a value 6? And it is not 1 by 6 because now we are not looking at these outcomes. We are not looking at these outcomes. So the chance that odd outcomes would occur is 3 by 6. Out of which I am concerned about a particular outcome, which is what the outcome I am interested in, and so this outcome occurs only once in the 3 outcomes, and so this probability is 1 by 3. Okay, now if I have to express this for this example that we have discussed, then suppose I am interested in 6 by 32. Okay, that is, what is the chance that this particular outcome would occur? That is, x takes a value 2, y takes a value 3. Okay, what is the chance of that event occurring? So probability that x is equal to 2, y is equal to 3 is 6 by 32. Okay, right? But if I know that x actually is occurred, okay, I have no knowledge about y. I have no knowledge about y. I have a knowledge about x. I know that x is 2. I know that x is 2. So x has taken a value 2. Then what is the probability that y will take a value 3? So probability of x is equal to 2, y is equal to 3 divided by probability that x takes a value 2, right? Probability that x takes a value 2. So that is 6 by 32 divided by probability of x takes a value 2 is 12 by 32. That is, the chances half or 0.5 that if we know that x has taken a value 2, then the chance that y will take a value 3 is 1/2. Now, so the occurrence of this event is not 6 by 32 now, because we know that we have a knowledge about one of the two components. We know what has happened to x, and since we know what has happened to x, I can actually find out probability of occurrence of y. So what I'm actually saying is probability of, so this is my conditional probability, that probability, I would perhaps say that probability that y takes a value yi, given x has taken a value xi, is expressed as a joint probability, that is probability that x takes a value xi, y takes a value yj, y takes a value yj, x takes a value xi, divided by probability of xi, right? Or to be consistent with my earlier expression, I would say probability that x takes a value xi, to be consistent with my earlier expression, right? Which means I can perhaps write this entire thing as probability of A given B is probability of A intersection B upon probability of B. Right? I think I should write it here. Probability of A given B is probability of A intersection B upon probability of B. Right? So I want to know probability of A given B has occurred. Probability of Y will take a value 3. Given X is value, X is taken a value 2 is probability of A intersection B. A intersection B. Yeah? A probability of A intersection B. Both A occurred and B occurred is A intersection B. That is 6 by 32 divided by probability of B. Right? This can further be written as probability of A given B is probability of A into probability of B given A upon probability of B, which also can be called as Bayes' rule. Okay, this is a conditional. This is the expression of conditional probability. What we perhaps also need to do is conditional expectation. So I can actually compute expectation of X given Y has taken a particular value. Okay, so I express conditional expectation as expectation of X given Y J. Okay, so which actually means that I take a value of X given given the probability of that value given Y, right? And I keep on computing it and I get the expectation. So I do the same thing, but what I need to do is I need to get expectation of X given Y is equal to 0. Expectation of X given Y is equal to 1. Expectation of X given Y is equal to 2. And so this would be called as conditional expectation. I can similarly compute a conditional variance. A conditional variance.
So you would compute the expectation like we have before. You wouldn't be dividing it by anything, right? You would simply compute part of the expectation.
Yeah. Absolutely. So probability that the expectation of X given Y, expectation of X given Y, say suppose I'm interested in Y takes a value 2, can be worked out in simple ways that X takes a value 0 to, so I would perhaps write probability that the first is X takes a value 0, I work it out, X takes a value 1, I work it out, X takes a value 2, I work it out, X takes a value 3, I work it out, I do the summation, that is, this is